almost lunch now, but we have a memory leak there. Take it away.
Thank you. Thank you. Good morning. So my name is Nikita. I am from a company named Plumber. We are just yet another Estonian startup. We solve performance problems, but I will not talk about our product today. And if you have read my Twitter from earlier today that I will talk to you about how bad our software is, I haven't meant our software as a company. We have a perfect product, but our software, all of our software is pretty bad in some sense. And this talk will be sad and depressing and miserable. So if you are here for some rainy unicorns, you're in the wrong room, please leave now. Because that will be sad and depressing talk, I promise you that. So what I will talk about today is memory leak. So you all know what memory leak is. More or less is a situation where you have some objects in your application which are still referenced by your application, so garbage collector cannot remove them, cannot clean them away, but your application will not use those objects anymore. That's our definition of memory leak. Essentially, these are alive objects that will not be used. And the problem with solving memory leaks is that notion of whether your application will use objects or not, that's totally application specific. You cannot, in general case, decide that in advance from the outside. That's, well, your business logic. Except there is one subclass of memory leaks, and that I will talk about today, is Classloader leak. I claim that that is the most common leak in web applications. In fact, it is so common that the title of this talk is I bet your application has a memory leak. I used to bet a real beer that your application, your web application, has at least one Classloader leak in it. Until someday some Russian guys won that bet and I don't bet beer anymore. Just in case. So, what is a Classloader leak and how it happens? Imagine you have a web application, your application server, and you, for some reason, undeploy that application. And wait a minute before you will start crying to me that we don't undeploy. So, when you undeploy your application, and imagine a situation when one object from your application was somehow left behind. And we will see examples of that situation plenty during the talk. So if you have at least one object left behind after application is undeployed, every object in JVM holds a reference to its class. So object holds a reference to its class. Every class holds a reference to its class loader. And at least in hotspot or in OpenJDK, let us put this way, in OpenJDK at least, every class loader has an array, or a vector, but well, has a vector of every classes that have been loaded by that class loader. And so we have a chain from one object in your application to its class loader, to every classes in your application. So every in one class that was there in your webinf lib folder is left behind in memory, is left behind in running JVM. But as your application is undeployed, that application will not use those objects and those classes anymore. And when you deploy the new version of the same application, that will not really reuse those objects. Every classes from your webinf lib and webinf classes folder will be loaded again, and you will have the second copy of those classes in your memory, and the first copy is essentially a leak. That's extremely common situation, and I will show you that. So, should you care? Maybe not. Because, well, first objection that I have heard about, well, we have now Java 8, it's modern days, we don't have permanent generation anymore where all those classes reside. We have metaspace, which is essentially unlimited. Okay, yes, true, you now have much larger room to fill with your garbage. That doesn't mean the problem went away, you still produce garbage. So maybe you are okay with littering huge space. Okay, I will let you live with that. And other objection, which our neighbors in Tartu always say, no redeploy, no problem. Fight redeploys. And you are right, maybe you don't redeploy your application. Maybe you just restart. You start up the second instance of your application and just switch your load balance. So that's not a problem for you. And you're absolutely right. The purpose of this talk and the goal of this talk, in fact, this one. I would like to raise awareness and to ask you as a developers why we produce this shitty code. Why we write so bad libraries, why we do not care about the users of our libraries, that our libraries leak. Why we don't think about users. We can do better. That's the sole purpose of this talk is for you to think, can I do better? Can I think about our users and not write that bad code? Because the majority of the leaks that you have in your applications, in your web application, they are not your fault. Classloader leaks, in the most cases, are the problem of your libraries, of your environment, of your infrastructure. You take, for example, what do? You start to write new application. You need a data source connection pool for that, database connection pool. What do? You go and Google what is the best data source on the market right now. Google will point you to Stack Overflow question, and Stack Overflow is always right? And you read the best data source right now is BoneCP, for example, 3 years ago was that. You take that library into your application or any other library because, well, Stack Overflow recommend that, so you cannot be fired by using Stack Overflow answer, right? Like, well, 10 years ago, you cannot be fired by buying IBM or WebSphere, for example. So you take that library into your application, and kaboom, you have a Classloader leak in your application. Because that's not usually you have no idea what lives in the dark ages of your web-in-flip folder. Because, for example, you do know that you use BoneCP, for example. Have you any ideas what libraries transitively are used by BoneCP? Have you looked into those libraries Jira or bug tracking to see if they have any bugs? I bet you haven't. So in general case, you have no idea what code do you use in your web application. Which means that you as a web application developer, so you part as a web application developers, are essentially at the mercy of this part, library developers. And I very like the advice that you should write your code as if it will be used by maniac sociopath who knows where you live. Can you sleep good at night right now if I would say that your code is used by some serial killer? Can you? Are you sure that your code is good? That you do not leak memory like I show you? So that's the purpose of this talk, to think about that and try to be better and try to make your code better. But okay, I'm bad at slides, so that's my last slide, and I will switch to live code demo. But how this talk and this demo have born is that 3 years ago, I was developing a first version of our client-facing web application. I was developing that in my IntelliJ, and well, I have changed some class, and I hit redeploy button in my IntelliJ because, well, I for some reason haven't used JRebel that time. So I hit redeploy button. My application was redeployed inside JT container, and then JVM crashed with out-of-memory permanent generation error. Let me remind you the first slide. I am from the company who solves memory leaks. So I have taken that error in my machine as a personal offense. And I have gone investigating that. 6 hours later, I have discovered 4 Classloader leaks in application that consisted of that time of 2 web pages. Tiny web application, 2 web pages, nothing fancy, is Hibernate, Spring, JSP, and WebSockets. And I have 4 Classloader leaks in that application of 2 web pages. I consider myself a good developer in the company whose sole purpose is that time was to solve memory leaks. Which means for me that, sorry guys, your application has Classloader leaks as well. If we had, you have. But so, let me switch to application. So let me close that. So what I have here, I have the ancient version of our portal running. So don't see the exact details and interface. That's not important. I have that running inside here in JT, and I will show you the code soon. And I will use Plumber to demonstrate leaks to you. You can solve and find all those problems without Plumber. That's not product pitch. Well, a little bit, but not really. So that's just easier to me to demonstrate those problems. So how that will work? So I have one application running here. And that application runs with Plumber. And Plumber communicates with current version of our portal on the same machine. So I have two applications, one old and new, running on the same machine and communicating with each other. So that's, well, generation talking to each other. It's rare thing we happen that. So two generations. So I will start my application. And we will have some pauses in the talk when that application redeploys. So if you have any questions, just ask them anytime, because we have plenty of pauses in that talk. Live demo. And I do hope that demo gods are favorable to me and the demo will work. If not, then I'll have some pre-generated reports to show it to you. So our application is running. Now I make a redeploy. And we'll see what happens. Will we find Classloader leaks or not? So, well, I surely hope that we will. But let's see. That will take a little bit time. So if you have any questions, that's a good time to ask them. No? Okay. So just look at how beautiful interface we have. No? It's about time. Yeah. So we have one leak. So what do we have here? Let me do that. So I hope you see. If not, I will read. So we have web app class loader leaked. That's the usual class loader that Jetty used to load your web application. And that is leaked because we have some thread pool executor running. So if your application or some library in that application uses Java util concurrent executor service or thread pool executor, very sensible thing to use. And that specific thread pool executor runs something named pool watch thread, com jewelbox bone CP. So okay, we have some leak concerning bone CP data source that I was talking about. What's wrong here? So again, I do not use executor service in that application. I just use a data source. And that data source apparently starts some thread pool to run its threads to do his job. That's good. Why, after application and deployment, the thread pool is still running? Turned out, for extremely simple reason, because I'm stupid. Yes, really. Because, let me show you the code. View presentation mode. So, whoa. Oh yeah, I have changed presentation mode font for my previous talk. Sorry guys. Presentation appearance. Yeah, that was, I believe. View exit presentation mode, view enter presentation mode. Too big. So I have a servlet initializer in my application, which when application starts, it creates a new data source, that servlet context listener. So whenever servlet context initialized, I create a new data source and then I reuse that for all my application. The problem being, when you create a data source in your application, what should you do when application dies? Obvious question. You should stop that data source, yes. And that one thing that I have just completely forgotten to do. Because, well, I'm a developer, I want to write new code. So, okay, new data source, okay, and now I have my database connection, now I'm off you go to writing that exciting business logic. Who think about data source closing? Pretty stupid mistake. I have made it. That means somebody else can make it. I really hope I'm not alone that stupid. So, okay, I have fixed that problem. So in this particular case, in the same context, server context listener, whenever our server is destroyed, I just close that data source. Simple. Let me write application again, and let me see if we can solve this problem and if we have other problems. Any questions so far? No? Okay. So if you start any resources, data sources, thread pools, whatever, you have to stop them. Pretty trivial example, but still. Where am I? Yeah, here. Redeploy. Redeploy. So now we redeploy, now Plumber starts analyzing what's going inside, has anything been left behind after that undeploy, and hopefully soon we'll see yet another leak. Yeah, 2 at once, perfect. One of them. The leak in Classloader is being held by a thread named Google command base internal finalizer. What the hell? I can give you my word, I have not used Google whatever finalizer in my application. I haven't, really. How can that appear there? Because that is a transitive dependency of the library that I really use. In this particular case, again, the very same BoneCP data source. And let me remind you, I'm very happy with BoneCP so far, and it was recommended as the best data source connection pool 3 years back. It's really good software, but still. So, some thread running inside my application that I have no idea what does it do, and how can I take a grab on that, and how can I close it. So, what should I do? I take a memory dump. I looked into the memory dump, what that. I read the code for 1 hour, trying to understand what that finalizer does. Eventually, it turned out that BoneCP starts that finalizer thread in order to monitor if you have some connections left opened. So you get connection from data source, you use that connection, and you forget to put that back into data source. In order to monitor for those problems, BoneCP starts that finalizer thread to monitor. The problem being, there is no public API to shut that thread down. So when your application is undeployed, thread is left behind. It will run forever. And you have a memory leak, because that class, that thread was started inside your application. It has context class loader, your web app class loader, so you have your leak. What should you do? In this particular case, I do not use data source directly. I do not work with connections directly. I use Spring JDBC template and Hibernate. So hopefully they will take care of those connections. So I feel like I am safe and my connection will not leak. So I just disable that connection track and functionality. And that thread will not start, so it will not leak. Okay, but we had 2 leaks here. The second leak. The leak in Classloader is being held by a thread named Abandoned Connection Cleanup. Something similar, yet another abandoned connection cleanup thread, finalizer by its functionality, exactly the same. The thread runs an instance of com.MySQL JDBC driver. Turns out that some MySQL JDBC drivers start a thread, again, abandoned connection cleanup, again to monitor if you have some leaked database connections. And they forgot to shut that thread down. How can you solve this problem? First of all, you go to your dependency management and you upgrade the version that was fixed in version 23. Wait a little bit. So you upgrade your version. That's not all. Then, when your application is being undeployed, or whenever you are done with JDBC, MySQL JDBC, you have to call abandoned connection cleanup thread.shutdown by hand. That thread wasn't there before version 23, so you had. Now, question: how should you know that? You are an application developer. You communicate with database. You take MySQL JDBC driver. How the hell should you know that you should do that dance? A magic incantation. How? Answer is You shouldn't. That's not your concern. You shouldn't think about that. You go to MySQL developer website, you download the jar file, or you just use your Maven Central or JCenter bin tray. Maybe you read some introductory documentation about how to start using that. Well, yeah, so you put that URL to your JDBC URL. That's all. Nobody never will tell you that you have to clean up some abandoned connection cleanup thread. Well, I have discovered that because there was a bug filed against the JDBC driver, and there in the comment it was told, okay, the solution is with the newer version of drivers to call that method. So the documentation that you're looking for is in bug tracking system. The first place that you go, of course. Okay. Hopefully we have killed those two problems as well. Let's go next. Any questions so far? No questions.
How do you do this memory leak tracking?
Oh, that's interesting topic. We have a product about that topic. Essentially, it's very easy. We monitor your web application, and when we see that application is undeployed, we see have we something left behind which uses that class loader, just in memory. So, does somebody references this class loader, and if, then why? So just find that change or threads or thread pools. Easy. Like one speaker told on VM Summit this Monday, easy peasy lemon squeezy. Easy. So we have started, now we redeploy. Let's see what we have here. So that's new session. Yeah, new session. I hope. Yeah. So, oh yeah, until we wait, I just give you a hint that we look for heap leaks as well, GC poses, and Threadlocal. So just by accident, you now see that we have more functionality in our awesome product, but I haven't told you that. So, redeploy, analysis, and we have a leak. That's fourth. Leak in Classloader is being held in com.mysql JDBC driver, which is held in Java SQL driver manager. That is perfect example of memory leak by specification. Really, that is a memory leak by specification. It was designed to leak. Really, I'm not kidding you. JDBC specification claims that for JDBC driver, for database driver, to be JDBC compliant, they has to register itself, to register the class, the driver implementation, on the startup in Java SQL driver manager. This is written in specification. What is not written in the specification is that you have to deregister that driver when you're finished. And Java SQL driver manager is a class loaded by Bootstrap class loader, so it lives forever. And it has a static reference, a static field, vector again, registered drivers. And it holds references to every driver that was loaded inside that web application. Fortunately, you have a way to fix that problem. You have just add a code like that to your application. So essentially what it does, it looks for that particular driver that you have loaded. Well, it should look up that. You have no way to, well, just have it. And then you call deregister. Fortunately, there is an official public API deregister only the specification has forgotten to mention that you should call that. Fortunately, again, for me, in my particular case, it's even easier because I just ask my BoneCP data source, deregister that driver whenever you close the data source. Now the question is that a little bit, well, trolling question, but the question is, why that option is not true by default? Why default situation is leaking? Well, in fact, I know answer, because, well, yeah, in some cases whenever your driver or your data source, well, your driver is in fact not in your web and lib, but in your application server lib folder, where in fact it should be, then really that should be false, because you have many data sources and only one driver, so yeah. But when I have found this, the question popped to my mind, why the default configuration is a leaking one. Okay, we have solved this. Let's start again. No question so far. Just ask if you have one. So application is started, not here, here. Now we make a redeploy. Yeah. So 4 leaks so far. 1 from the library, 2 from the library, 3 from database driver, 4 from database driver by specification. Okay. At least you can tell that's not my fault. That's not the code I wrote. One more. Leak Classloader, web app Classloader, leaking Classloader held in EU plumber betutil Threadlocal stop. Threadlocals. Threadlocals are very useful utility. What many developers who use Threadlocals forget is that essentially Threadlocals are custom scope for your values. In Java, you have 3 scopes for your values. You have method local values, which is variables which live inside one method. You have instance fields, which lives as long as this particular object lives. You have static fields, which lives as long as this class lives. And with the help of Threadlocal, you can implement your custom scope. You can have a value which lives as long as you wish it to. The problem here is, whenever you start using custom scope, it's your responsibility to say when that scope ends. You put some value into Threadlocal for it to live as long as you need, and then you have to clean that value up when you don't need it anymore. If you don't do that, that value will live in that thread. And in web application environment, the majority of the threads that your application uses are not yours. Those threads came from application server, which means that that Threadlocal value will live long after your application has died. So you have to put Threadlocal clean. Or, like in our cases, when we just discover that in this particular case, we use Threadlocal to implement some stopwatch. How long this method has run. So we start watch before method, and we stop the watch after that. Problem is that we forget to clean that Threadlocal variable. Now the question is, why the hell do we need Threadlocals here? We don't. Just local variable and our problem solved. But on the start, it seems that, well, that's exactly the case for Threadlocal. Perfect. Turns out, not. So one of the ways to solve a problem with some thing is don't use that thing. So don't use Threadlocal unless you know what you're doing. Okay. One more down. So that's 5. Yep, 5 so far. Our application is up and running, and we make a redeploy. Yeah, where is my redeploy? Yeah, here is my redeploy. Questions? We have time.
You mentioned the placement of JDBC drivers.
Yeah.
Application
Versus application server. Yeah.
application server or application when using a database pool.
Yeah.
Which is the best place?
Unless you have some specific reasons to do otherwise, I think that the correct way is to put that into application server. But here's the trick. We started our application, like you see, with when we have the JDBC driver inside application. Then we have moved that into application server. And months back, we have moved it back. Just the reason because, well, it's simpler for us to configure and use data source inside our application and inside. So up to you, in fact. You just have to know that if you have driver inside your application, life cycles are different, lifetimes are different. You should handle that. Web app Classloader is being held by EU Plumber bet-util statlog level in level objects of Java-util logging. That's one more example that I very love, that you have a memory leak, you have a Classloader leak in your application, which is not your fault at all. Because in this particular case, JDK leaks. I'm not sure this is by design, which means which is polite way to say I'm not sure everybody thought about design of that thing at all. Because, well, it seems to me they just have written some arbitrary lines of code, because we have Java-util logging framework built into JDK, which allows you to define your own log levels. We have standard ones, trace, info, debug, error, warn, in Java-util logging, and fine and finest and whatever, and you can define your own logging levels. And before you ask me, why should I do that? Am I that stupid? Why? Well, maybe you are not. You really don't do that. The problem is, some developers out there do use custom log levels. For example, JBoss developers. Some JBoss products do use custom log levels. And whenever your application has a custom log level, again, that's not by design, by implementation, let me say it that way. By implementation, Java-util logging level class holds a reference to every custom log level class in your application. That's private static variable without any public API. You have no official public way to clean that class from that static reference. Which means that as soon as you have custom log level in your application, you have a class loader leak that you have no ways, official ways, to solve. Really. You have to hack inside a level class by reflection, get that private static field, iterate over all log levels, find your own, and clear that up. Extremely obvious and transparent. Like, well, everybody knows that. Your toddler knows that. But I am lazy guy. I have just decided, okay, screw log levels. We will not use custom log levels in our application. But if you use the library which uses log level, sorry, you have to use your reflection skills and hack inside JavaOT login class. Okay. More? Anybody for some more? Uh-huh.
You said it in the beginning. You can also just restart the JVM. You don't have all this chaos and all the problems. But I forgot why you didn't do that.
Well, we do that.
Yes.
We do that in production.
Do it too, and certainly after this talk.
Yes. The problem is, like I said, the purpose of this talk is not to make your redeploys painless, because, well, redeploys is always pain, and why do you do that? The point of this talk is to show you how bad code do you write. When you are a library developer, why you write code which leads to those problems? That's the sole purpose of this talk. To force you feel sad and miserable. Yeah, I'm evil guy on that. I believe in shock therapy. So I hope to show you how bad your code is, and you will be enlightened, and we'll start write better code tomorrow morning or today evening. Yeah, I'm naive optimist. Okay, where is our redeploy? Okay. Yeah, one more. Oh, okay. I have bug in my local application. Sure. Yeah. Why don't you want to show me that? Or I have stumbled upon some new leak that I don't know about. That's strange. Okay, demo goats are not that kind to me. Okay, where was I? Okay, here's my account. I have problem, account ID. So a little bit hacking, and we. Yeah. Okay, yeah, that's good. So whenever you have permissions issues, we just hack the database directly. That's interesting problem. I hope we will solve that, because, well, if I hadn't that in my database, that may be something fishy going on there. So, what's interesting about that problem is that in this leak report, there is no class from my application. There is no class from any library of my application. It's totally Jetty and JDK. Yeah, Jetty is over here. Jetty and JDK. So what the heck? Now, let me show you how to solve that. And I hope that we'll solve that, but, well, demo goats. So in order to solve that particular class loader leak, what you have to do is to go to your run configuration, take run configuration, and say that application server that you use is the latest version. And then you stop server and you run server and see if you can fix that. So the problem here is, hopefully that problem, is that I used JT version 8, which has, or had, some problems which leaked class loaders. Some session-related management was not cleaned up after application was undeployed. So not only your libraries that you have downloaded from the internet leak, not only JDBC drivers that you well rely upon leak, your application servers leak. How good is that? Do you feel sad? Let me see if that's all. Yeah. Now it's latest 9, and that was fixed in some early versions of JT9. I don't remember exact, but some early versions of 9. Oh, one more leak. We're not done yet, and we have only 4 minutes left. Okay, that's easy. That's easy. That's my BoneCP data source again, and we have JavaX naming and JNDI. Again, that we have started with developers error when I have forgotten to close data source. We finish with developer error when on my application start, I publish something into JNDI tree, and which means that whenever you are done, you have to unpublish that. Again, as simple as that. Again, that recurrent scheme, you started something, data source, you put something somewhere outside of your control, Threadlocal. You publish something for outside world, JNDI tree. It's your responsibility to clean after yourself. So, yeah. And I hope we have time to see a green light. I hope. Yeah. Okay, at last. I have waited for that question from the beginning. That, unfortunately, our design decision.
The question.
The question was, sorry, yeah. The question was why I find those leaks one by one. So I make redeploy, we find one leak, we fix that, we make redeploy, we find another leak. That, unfortunately, was a design decision of Plumber 3 years ago, and we still suffer from that till date. So that's just our problem. When you solve memory class loader leaks manually using, for example, Eclipse Memory Analyzer, you can solve them in one way or in one go, usually. So that's just tool shortcoming. Sorry. So we have started redeploy, yeah, and let's hope we will see a green light. Any more questions? Yeah, ask. I don't see you anyway. Sorry, no. We don't find memory leaks on Android applications because, first of all, because Android JVM Dalvik is a little bit different from usually your desktop JVM. So no, we cannot help you with that. Shall we? Yeah, and we have a green light. So thank you. Thank you. If you have any questions, you can find me in the hall. I will be here until 4 o'clock. If you have any questions, thank you for your attention.